Okay, welcome back to Step Electrical friends. Today we are going to discuss a numerical problem of nodal analysis. So let's start. And this will be the part 2 of nodal analysis. So here, as we have discussed earlier, that there are 4 types of circuits that we have to solve in nodal analysis, and the very first type is circuit containing only current source. So here the circuit is, this is the circuit in which there are only current sources. Current sources I supplying I1 current sources, this current source supplying I2 current, and this third one current source which supplies I3 current. So there in this network, in this circuit, there are only current sources which are supplying the current to these resistors throughout this circuit. So in simple, we can say that this is a circuit having only current source. Okay, so let's start. First of all, we will assume A, B, C and D as the nodes. We assume the very first step that we have to do for nodal analysis is in each of this circuit, but for this circuit we assume here A, B, C and D are the nodes of these nodes for this circuit. Okay, the next step, node D is assumed as reference node. So here it is grounded. Okay, now we have also to assume that VA, VB and VC and VD with the voltage of the nodes A, B, C and D. So the voltage at the node VA is, at the node A is VA, voltage at the node B is VB, and voltage at the node C is VC, while voltage at the node D is VD. Node D is grounded, or D is considered as reference node. VD is equal to 0 volt. Okay, this is the very first thing that we have to do for nodal analysis. Okay, let's move ahead. Now we will apply KCL at node A. Similarly, we will also apply KCL at node B, and finally we will apply KCL at node C. There are 4 nodes, but the fourth one is reference node, so we don't have to apply KCL at node D. So we can conclude that we will apply KCL at only 3 nodes, node A, node B and node C. Once we apply KCL at node A, let's redraw the circuit. And here I have omitted all other elements that have no concern with node A. And now let's write KCL equation. Before that, we will also assume the current. So here I1 is the current which is entering this node A, but IR1, IR2 and IR6 are the currents passing through. IR1 passes through R1 resistor, IR2 passes through R2 resistor, and IR6 passes through R6 resistor. So these all are the currents IR1, IR2 and IR6 which leave the junction A, but I1 is the current entering the junction, and we know KCL equation is nothing, just the summation of incoming current is equal to the summation of outgoing current. So let's write KCL equation. Here IR1, IR2 and IR6 are their summation must be equal to the current entering the junction. So I1 is the only current entering the junction, entering the node A. So now we will replace this I1, I2 and IR1, IR2 and IR6 and I1 by their values using Ohm's law. So once we apply Ohm's law, here IR1 is equal to VA minus 0 by R1. VA, potential at the node here, VA minus 0. The current is leaving the junction, so VA is at highest potential. That's why it is written as VA minus 0 upon R1. Similarly, IR2 is written as VA minus VB upon R2. Why? Because node A is considered at high potential and node B at low potential. That's why the current IR2 moving from A to B. So we can write VA minus VB upon R2. Okay, similarly for IR6 we write VA minus VC upon R6. And finally this one I1 is not replaced. Why? Because its value is given. Here I1 is known. That's why we don't have to use Ohm's law or anything else. Just put the value of I1. So this is all what we have to do for applying KCL at node A. Okay friends, it's my request, if you find this video interesting, okay, so let's move ahead. Now we will apply KCL at node B. At node B, once again we will omit all other elements and branches that have no concern with node B. Okay, so we will get these types of network. So let's assume the current here. IR2 is the current flowing from B to A. IR3 is the current flowing from B to C, and IR4 is the current flowing from B to D. While I2 is the only current which enters the node B. So we can apply KCL and we can write the KCL equation as IR2 plus IR4 plus IR3 is equal to I2. IR2 plus IR4 plus IR3 is equal to I2. Here I2 is the only current entering the junction. Now it's time to replace this equation. So now let's write the equation as VB minus VA upon R2 plus VB minus 0 upon R4 plus VB minus BC upon R3. Why VB minus VA upon R2? VB minus VA. R2 current, IR2 current is VB minus VA. VB is at a high potential, current is flowing from B to A. That's why we can write VB minus VA upon R2. Similarly, IR4 current is VB minus 0. VB is the current is flowing from B to D, and D, the potential at D is 0. That's why we write VB minus 0 upon R4. Similarly, for IR3, here VB is at high potential and current is leaving the junction, leaving the node. That's why we can write VB minus BC upon R3 is equal to I2. So this is the second equation, and we have applied KCL at node B. Similarly, we will also apply KCL at node C. So let's move ahead. Okay, once again, as we apply KCL at node C, for our easy and convenience, we will omit all other elements and branches that have no concern with node C. Okay, now it's time to apply KCL at node C. So let's apply KCL at node C, and we will get the network like this. First of all, we see that I3 is the only current which we assume I3 is the only current which enters the junction, which enters the node C, but IR5, IR3 and IR6 are the current which leaves the junction. So we can apply KCL and we can write KCL equation as IR3 plus IR5 plus IR6 is equal to I3. Now it's time to replace this equation by its equivalent using Ohm's law. So we write VC minus VB upon R3 plus VC minus 0 upon R5 plus VC minus B upon R6 is equal to I3. And finally we have got three equations. On solving these equations, we will get the values of VA, VB, BC, VA, VB and BC. So it is the general way to analyze any circuit using nodal analysis only containing current sources. So as we have done in the general analysis, now we will follow the same steps and solve this numerical. So very first step that we have to do is we have to assume that A, B, C and D are the nodes, where D is the reference node and VD is equal to VA, VB, BC and VD are the voltage of the nodes A, B, C and D respectively, where D is the VD is equal to 0 volt. So this is the very first step. Now we will apply KCL at node A, at node B and at node C. So on applying KCL at node A, we get I8 plus I4 plus I6 is equal to 10. I8 is this one, the current flowing from A to D, that is I8. So I4 is the current flowing through this 4 ohm resistor from A to B, and I6 is the current flowing from node A to C through this 6 ohm resistor. So here I8 is replaced by VA minus 0 upon 8 plus VA minus VB upon 4 plus VA minus BC upon 6 is equal to 10. How and why we have already discussed in general discussion. Okay, so let's apply. On simplifying, we will get 0.542 VA minus 0.25 VB minus 0.16 VC is equal to 10. This is the first equation. Now we will apply KCL at node B. Okay, on applying KCL at node B, we can write I4 plus I5 plus I8 is equal to 5. I4 current leaving the junction, current leaving the node B. So I4, I5 is the current leaving the junction flowing from B to D. This is I5 current, and I8 is the current flowing through from B to C through resistor 8 ohm. So we can write I4 plus I5 plus I8 is equal to 5. Why 5? Because 5 ampere is the only current entering the node B. And now we will replace it very easily. So on solving these all, we get minus 0.25 BA plus 0.575 BB minus 0.125 BC is equal to 5. And this is the second equation. And now let's apply KCL at node C. So on applying KCL at node C, we write I8 plus I6 plus I6 is equal to 8. Here I8 plus I6 plus I6 is equal to 8. Here I6 is the current. I8 is the current flowing from C to B, and from C to B. I6 is the current flowing from C to D, from C to D, and again here I6 is the current flowing from C to A. So we can easily replace this equation, this current, by their respective equivalent value, that is Vc minus Vb upon 8 plus Vc minus 0 upon 6 plus Vc minus V upon 6 is equal to 8. We have done nothing, just use Ohm's law, I equals V by R. And on solving, we get minus 0.167 VA minus 0.125 VB plus 0.4583 VC is equal to 8. So now it's time to solve these three equations that we have obtained while applying KCL at node A, node B and node C. So let's see. Here on solving these three equations, we get VA equals 52.67 volt, VB equals 42.06 volt, VC equals 48.12 volt, and this is the required result. We have completed all these things, but now it's time to verify the result using circuit lab. Okay, here VA is 52.67 volt. VA is 52.67 and the result is 52.65, so it is same. Okay, now VB is 42.06 and here the in result we obtain 41, and VC is 48.07 volt. So, and this VD is 0 volt. So we have easily proved and that the numerical that we have solved is correct.